I am Raghavan, Chemistry faculty from All Force College. I welcome you all for All Force Chemistry Learning Program, session 16th. Okay. In last session we completed the numerical concepts of radius of Bohr's orbit, that is species containing one electron. According to Bohr's theory, we know that Bohr's theory can explain the spectrum of one electron containing species like hydrogen atom or helium ion, lithium 2 plus ion and beryllium 3 plus ion. Okay, so till last session we completed the numericals on radius. Okay, and few, that is we have done the radius, that is energy equation also we derived in the previous sessions. That is derivation of the radius of the Bohr's orbit we have done, and derive the equation to calculate energy of the electron also completed. Derive the velocity expression to calculate velocity of the electron in the nth orbit, that also done. And we also done the number of revolutions made by the electron around the nucleus per second, that is also completed. And we also done the number of waves made by the electron, okay, around the nucleus, that also completed. So now we are coming to the numerical orientation concept on that. So now energy of the electron, energy of electron in the orbit, energy of electron in the orbit, energy of electron, energy of electron in the orbit is given by, that is energy of the electron in the nth orbit of species containing one electron. It may be hydrogen atom, or it may be hydrogen atom or helium plus, helium plus, helium plus, lithium 2 plus or beryllium 3 plus. The species which containing one electron, okay, that is equals to minus 2 pi square m z square e to the power 4 by n square h square. So this equation is useful to calculate energy of the electron in nth orbit. Okay, that is, we should remember that. Now what are the values of this? Pi is equals to 3.14. we know that. M is equals to mass of the electron, that say for example it is 9.1 into 10 to the power minus 28 grams. And Z, species whose atomic number is 1. Say now hydrogen atomic number is 1, Z for hydrogen is 1. And E, charge on electron, charge on electron, we should not forget the fundamentals, that is in CGS units, charge on electron is 4.8 into 10 to the power minus 10 ESU, electrostatic units. Okay, then N is equals to orbit. In which orbit of hydrogen? First orbit of hydrogen. So that is first orbit of hydrogen atom. Okay, N is equals to 1 for first orbit of hydrogen atom, that is 1. First orbit of hydrogen atom. Make it clear, let us write. So first orbit of hydrogen, that is equals to first orbit of hydrogen atom. Done. H is equals to Planck's constant. H is equals to Planck's constant value is 6.625 into 10 to the power minus 27 ergs second. Remember always, it is not per second, it is erg second. Okay, so the values of this substitute in the formula, in this formula. So then that is equals to, you will get energy of the electron in the first orbit of hydrogen. Energy of the electron in the first orbit of hydrogen is calculated as, let us substitute, minus 2 into pi 3.14 whole square into m, mass of the electron, 9.1 into 10 to the power minus 28 grams into Z, atomic number of hydrogen is 1. Okay, so that is 1. Next, charge on the electron is 4.8 into 10 to the power minus 10 ESU, okay, to the power 4 by n square orbit. So in hydrogen atom the electron is present in first orbit, so that is 1 square, okay, and into, okay, h is the Planck's constant value, that is 6.625 into 10 to the power minus 27 square whole square. So this is the substitution of all the values in the formula. Then we can calculate energy of the electron in the first orbit of hydrogen as minus 2.17, okay, so 2.1776, so you can make it 2.178, okay, into 10 to the power 8, no, it is 10 to the power 11 ergs per atom, so this much erg per atom, okay. So next is erg per atom, okay. This is energy of the electron in the first orbit of hydrogen atom in ergs per atom, okay. Should be very careful in this. We should remember all these values, okay. We should remember all these values. So next, same energy of the electron in terms of joules per atom, that is minus 2.178 into 10 to the power, okay, into 10 to the power minus 11. Now it is 10 to the power minus 7, okay, 10 to the power minus 18 joule per atom, okay, or it is equals to minus, as we know that 1 electron volt is equals to 1.602 into 10 to the power minus 19 joules. So now you will get, so that is equals to 13.6 electron volt per atom, okay, or that is equals to minus 1312 kilojoule per mole. Now it is per mole, remember it is per atom, joule per atom, now it is joule per mole. Per mole means what? Per Avogadro number of, okay, hydrogen atoms. This is the energy calculated per Avogadro number of hydrogen atoms. So next, that is equals to minus 13.6 kilocalorie per mole, okay. These are the, that is energy of hydrogen atom, that is energy of the electron in hydrogen atom in terms of different units, okay. For all the numericals, all these values you should remember all the values, okay. So that is very, very important for us, okay. 10 to the power minus 11 ergs, 10 to the power minus 18 joules, okay. It is erg per atom, it is joule per atom, now it is electron volt per atom, okay. Should be very careful, and it is kilojoule per mole, okay. Per mole means Avogadro number of atoms. This is also kilocalorie per mole, okay. This is the general representation of energy of electron of the species containing 1 electron, okay. The description is clear, okay. This is the calculation. Now the number, that is the energy of the electron in the nth orbit of hydrogen atom. For example, I want to calculate energy of the electron in the second orbit of hydrogen, okay, or I want to calculate energy of the electron in the third orbit of helium plus, that means species containing 1 electron, okay. Now this is for hydrogen atom, nth orbit formula is representation like this, and for first orbit of hydrogen the data is available like this, and substitution will get the values in energy of the electron in the first orbit of hydrogen atom, okay. That is in terms of ergs atom, the ergs per atom. Okay, remember the values. The values are very, very important. Okay, you should remember all the values. Okay, right. Now let us take up energy of the electron in nth orbit of hydrogen, shortcut. Okay, because using this, so we can say this is energy of this as minus E1. That means what? Energy of the electron in the first orbit of hydrogen atom. First orbit of hydrogen. That is given like this. Okay. Now let us see energy of the electron in the here only let us work on this. Yes, energy of electron in second orbit of hydrogen atom. Energy of the electron in the second orbit of hydrogen atom, that is equals to energy of the electron in the first orbit of hydrogen. Energy of the electron in the first orbit of hydrogen, it may consider in any unit. Okay, that is why energy of the electron in the first orbit of hydrogen. Okay, so first orbit of H by n square, remember that is the important point. Energy of the electron in nth orbit, you can say nth orbit of hydrogen is equals to energy of the electron in the first orbit of hydrogen atom by n square. That gives energy of the electron in the nth orbit. Okay, let us work out the example, same example. That is equals to energy of the electron in terms of electron volts. Let us take up this. So that is minus 13.6 electron volts by second orbit we are discussing, that is 2 square n square, that is n square, 2 square means 4, that is equals to, so 15.6 by 4, 15.6 by 4, that is minus 3.4 electron volts. That is energy of the electron in the second orbit of hydrogen atom. Okay, energy of the electron in the second orbit of hydrogen atom is how much? Minus 3.4 electron volts. Let us see one more. Energy of the electron in the third orbit of hydrogen atom using the same formula. Okay, so energy of electron in the third orbit of hydrogen atom, that is equals to minus 13.6 electron volts by n square means 3 square. 3 square means 9. That is equals to minus 1.51 electron volts. 1.51 electron volts. So this is energy of the electron in the first orbit. We have done first orbit is 13.6. We know that. Second orbit how much? Minus 3.4 electron volts, and third orbit it is minus 1.51 electron volts. So that is this is where we can calculate energy of the electron in the nth orbit of hydrogen atom. Okay, nth orbit of hydrogen like this, using this one, nth orbit of hydrogen. Next, let us calculate energy of the electron in the nth orbit of species containing one electron. Okay, we can calculate energy of the electron in the nth orbit of species like hydrogen atom, means which contain one electron. Okay, that formula is energy of the electron in nth orbit of species containing hydrogen, like hydrogen, that is it may be hydrogen atom, or okay, or it may be helium plus, He plus, or it may be lithium 2 plus, or it may be beryllium 3 plus. So for these species we can use the formula like minus energy of the electron in the first orbit, it may be in terms of any that is based on the question. Okay, it may be in any units, by n square, okay, into z square, so that is the concept of this, because into n square and by n square into z square, that we can apply as the concept to calculate energy of the electron in the nth orbit of species which containing one electron, like this. Okay, now let us work on some numerical, some examples like that. This is the basic the discussion based on the energy of the electron in the nth orbit. So nth orbit of hydrogen and the nth orbit of species containing one electron. So that is done. Okay. Now say, let us say the question is, say question number 1. Calculate ionization energy of helium plus, okay, or we can say ionization energy of hydrogen atom is minus 13.6 electron volts. Calculate ionization energy of helium plus. That is first question. Similarly, calculate ionization energy of lithium 2 plus. Similarly, you can calculate ionization energy of beryllium 3 plus also. Okay, let us work on this. Calculate ionization energy of helium plus. Ionization energy of helium plus ion is equals to ionization energy of hydrogen atom, that is minus 13.6 electron volts by n square into z square. Okay, as we know that here. So helium, that electron present in first orbit only, so no need to mention by 1 square. Okay, into z square. Z for helium atomic number is 2 square. That means 2 square. Okay, let us write it 2 square. And in the next step, minus 13.6 electron volts into 4. That gives minus 54.4 electron volts. 54.4 electron volts. Okay, and similarly we can also calculate for lithium. Okay, ionization energy of lithium ion is equals to lithium 2 plus ion, that is equals to ionization energy of hydrogen atom in electron volts. Okay, it is given, okay, by 1 square, because the electron present in lithium is first orbit only, that is by 1 square, and okay, plus 2 means the atomic number of lithium is 3. So 3 square means it is 9. 3 square means 9. So therefore it is equals to, so it is minus 122.2 electron volts. 25 nearly, it is 122.25 electron volts. Okay, that is ionization energy of helium plus and lithium plus 2 calculation. Okay, that is into z square. That is the point we should remember. So that is ionization energy of the species which containing one electron, that is equals to ionization energy of the species in the first orbit by n square into z square. That is a point to be remembered in this. Okay, that is ionization energy like this. Now see the numericals you can also expect. This is one numerical, that is nth orbit. Next, in hydrogen atom, nth orbit. In nth orbit of species containing one electron like this, we can also expect. Next, simple calculations like hydrogen is given and he is asking us to calculate ionization energy of helium plus or lithium 2 plus like this. And we can also expect like, see, we have potential energy, we know that, and we know that kinetic energy also, and we know the total energy also. Based on the total energy also we can expect the numericals. Okay, like what is the potential energy of electron? Potential energy of the electron is given by, did you remember that? Potential energy is equals to, that is potential energy of the electron is equals to minus ZE square by R, and kinetic energy of the electron is given by half mv square. Okay, so that is given as ZE square by 2R. So therefore the total energy is equals to, that means sum of the kinetic energy and potential energy. That means ZE square by 2R minus ZE square by R. That means minus ZE square by 2R. Okay, that is the total energy. Okay, so based on this total energy, see for example, the energy of the electron, the energy of the electron is given. See for example, I am taking, so this is the formula I am using now. So now I am preparing the numerical on this. Okay, the energy of the electron is, say, energy of the electron is 17.6 into 10 to the power 8 joules per atom. Okay, joules per atom. Okay, then joules per atom. R, instead of that let us use like this. Energy of the electron in hydrogen atom. Energy of the electron in hydrogen atom is minus 2.178 into 10 to the power minus 18 joule per atom. Okay, you got my point. Energy of the electron in hydrogen atom. Energy of the electron in hydrogen atom is given like this. Okay, energy of the electron in hydrogen atom is given like this. That is minus 2.178 into 10 to the power minus 18 joule per atom. Okay, and radius of orbit of hydrogen atom is 0.529 angstroms. Okay, now calculate energy of the electron in that orbit. Calculate, okay, charge of the electron in that orbit. Calculate, not energy, calculate charge of the electron in that orbit. Okay, that means total energy is equal to is available. I'll write here. That is total energy, how much it is given? Minus 2.178 into 10 to the power minus 18 joules. Okay, joules. That is equals to, so that is Z for hydrogen is only 1. So then minus E square by 2R, 2 into radius is available. Radius is 0.529 angstrom unit is equals to, as we know that 1 angstrom unit is equals to 10 to the power minus 8 centimeters. Okay, that is why 10 to the power minus 8 centimeters. Now you are calculating this. That is E is equals to how much we can calculate. So charge of the electron is calculated as, that is minus 4.8 into 10 to the power minus 10 ESU. Okay, that is the charge on the electron. Because why it is only 4.8 into 10 to the power minus 10? Because all the values are considered in that is, it is given in joules. So it is given in joules, it is available in joules. So therefore, okay, if it is available joules, now it is 10 to the power minus 10 meters. Then we can say here it is. So when it is in meters, it is in joules, then the answer will be minus 1.602 into 10 to the power minus 19 coulombs. That is the charge present on one electron. If it is in ergs and the radius will be in centimeters, okay, then we can say 4.8 into 10 to the power minus 10 ESU, electrostatic units. That is CGS. Now it is already given in joules. Now we should consider the angstrom in meters. So therefore now we will get coulombs. Okay, right. So like this. So here we have made one problem like this. What is the problem here we made? So that is, once again I will repeat. The energy of the electron in hydrogen atom is minus 2.178 into 10 to the power minus 8 joules per atom. And the radius of the orbit is 0.529 angstroms. Calculate energy of the electron, calculate charge of the electron, charge on that electron. Calculate charge on that electron. So as we know that, so total energy is equals to minus ZE square by 2R. Okay, that is, this is energy, total energy is equals to Z minus E square by 2R, radius is given. We can calculate charge on the electron is like this. This is to calculate charge on the electron. Okay, that is done. Now, so these are some fundamental formulas and how we can apply the concept to calculate energy of the electron in the nth orbit of hydrogen and energy of the electron in the nth orbit of species like hydrogen. And based on, see, another important point in this is, what is the ratio between potential energy, kinetic energy and total energy? Very, very important question, deadly important question. Okay, for all your mains and EAMCET examinations. Okay, that is the ratio between, you should remember them. Okay, that is like this. This is potential energy and this is kinetic energy and this is our total energy. Okay, we should remember them. The ratio, you can expect kinetic energy to potential energy or total energy to potential energy or anything else. Okay, the ratio between potential energy, the ratio between potential energy to kinetic energy to total energy, that we can explain it as, okay, that is equals to minus 2 is to 1 is to minus 1. The ratio between, okay, that is potential energy, kinetic energy and total energy can be expressed like this. Okay, the ratios are very, very important for the objective examination slide. Okay, this is one important point I wanted to mention, and that is clear. And the ratio between potential energies, that also we can solve from this. Okay, what is the total energy of the electron in the orbit? That is minus ZE square by 2R. Directly you can expect that is big. So one of the option is minus ZE square by 2R. That is the total energy representation. The potential energy of the electron is given by minus ZE square by R. Or you can say minus E square by R. Okay. So kinetic energy is equals to, that is E square by 2R. Total energy is equals to minus E square by 2R. Okay. So that questions we can expect for the objective examinations. So we have so many numericals based on this. Okay, this is the energy calculation in nth orbit of hydrogen, energy calculation in nth orbit of species like hydrogen. Let us use the same energy relation in hydrogen spectra. Okay, let us go ahead. So according to Rydberg's equation, what is the concept of Rydberg's equation? Concept of Rydberg's equation, yes, that is nu bar is equals to, that is a Rydberg's equation. Rydberg's equation, nu bar is equals to 1 by lambda is equals to R hydrogen into Z square, we know that, into 1 by N1 square minus 1 by N2 square. So this is Rydberg's equation to calculate wave number. Okay, and we know that, okay, so what is the relation between energy and wave number? So as here I'll write, E is equals to hc nu bar. Okay, let us use this. In place of this, we can introduce E is equals to h, E is equals to hc. This is nu bar. Okay, you can proceed. So nu bar is nothing but this is 1 by lambda. Okay, this is hc nu bar. hc nu bar, it continuous. E is equals to hc nu bar. Okay, it goes like this. So we can also use this formula to calculate. It is related to energy of the orbit. Okay, energy of the orbit. When electron is jumping from 5th orbit to 2nd orbit, calculate energy of the spectral line obtained. Okay, so RH is equals to Rydberg's constant value for hydrogen. Okay, as we know that it is only the constant for a particular element. So for element to element it changes, that is into Z square, that is applicable. So H is the Planck's constant value and C is the velocity of light, we know that. Okay, like that we can use the relation to that, we can extend to the hydrogen spectra also. One more formula like this, that is delta E is equals to E2 minus E1. We know that E2 minus E1, that is equals to quantum energy or photon energy. Okay, so therefore the difference in energy is equals to E2 minus E1, that is equals to, that is E2 minus E1 is equals to, calculate photon energy. Okay, that is nu is equals to delta E by H. We can also calculate, we can calculate frequency in this. We can calculate frequency, nu is equals to delta E by H. Delta E is equals to, that is nothing but E2 minus E1. This is equals to E2 minus E1. Okay, so by H. So based on the concept of the given problem, we can apply the formula for the, to calculate energy of the electron in the given orbit. Okay, right. So in the next session we have to solve the numericals on this.